Well, first of all, thank you for attending tonight. This is going to be a slightly different approach. This is going to be a more open type of lecture. And what I would like to do is to begin with what the future will be. And this is what this particular presentation will be like. So this is the human brain, as you probably have seen on many occasions. But in actual fact, that's not the real human brain. The human brain is alive. And if you measured it, this is what it would look like. Those flashing patterns you see there are the actual activity of a real brain. We've taken an EEG, quantified it, and we can actually see the activity taking place over the left and right hemispheres. The yellow and the red that you see is effectively what's going on as the person is sitting quietly. There's microstates going on here, being recreated every 20 milliseconds, 50 times a second. There are about 4 basic microstatic patterns, which are the building blocks to consciousness, just like pairs, sets of DNA or base pairs are the information for the last 3 billion years of genetics. Person's quiet. So the question is, suppose you have had access to information within every other person's brain and they had access to yours. What would happen? Has it happened? Can it happen? And what would it mean for the future of human societies? No more secrets. And tonight, that's exactly what we're talking about. Suppose you had access to the information of every other brain on this planet. No more secrets. Are we all connected? And the answer is yes. We are all immersed in the Earth's magnetic field. The human species is about 7 billion conductive brains, all sharing this field. Think of 7 billion wires, all immersed in the Earth's magnetic field. This field contains enough energy to store the experience of every human being who has ever lived. It's an easy calculation. Just think about that. All the information of every human brain that's ever lived has the potential to be stored in the Earth's magnetic field with lots of energy left over. There's the Earth's magnetic field. You've seen it on many occasions. In fact, the strength of the magnetic field induced in every brain, right now you're being induced, to put it this way, you are immersed in the Earth's magnetic field, is penetrating through your brain, through your body. And in fact, the strength of the magnetic field induced in every brain by the Earth's magnetic field, when all brains are considered, is almost identical to the strength that each brain generates. Your brain generates in the order of about a picotesla, which is about a trillionth of a Tesla, much weaker than the Earth's magnetic field. But that's the operational intensity. But what does it mean? It means simply this: such convergence produces the conditions that allow global resonance and the possibility of a human hologram. That is, 7 billion brains, basically immersed in the Earth's magnetic field, all with similar intensities, the whole equal the sum, and the sum equal the individual equal the sum. That sets up the conditions for a hologram. Calculations suggest that the time required for an event in one human brain to diffuse into all other human brains on this planet would be about 10 minutes. And it would recur primarily during dreams or during altered states. In other words, you can actually calculate it. 7 billion brains is an easy calculation. One brain, something you're thinking about right now, how long would it take if we're all connected to diffuse to every other human brain on this planet? About 10 minutes, and optimally during dreaming, when the right hemisphere is dominant. So here's how it would look in terms of an animation. Effectively, there's the representation of the 7 billion brains, almost 7 billion. And ultimately, this connection would take place over time in roughly about 10 to 15 minutes, particularly if you're dreaming, because there's something very different about the right side of the brain, the right hemisphere. Now, has there been evidence that such connections occur? Yes, for decades, verified cases indicate that some people's sudden experiences about a crisis to or death of a loved one occurs on days when geomagnetic activity is quietest. The experiences usually occur during a dream state. Let me give you an example. On the evening of the 5th of January, I was visiting, this is from a middle-aged woman. This is one of many cases. These kinds of cases have been recorded certainly since the 1870s. Massive booklets containing this information. On the evening of the 5th of January, I was visiting in my kitchen with some friends. Suddenly, I felt my face flush and I felt ill. In a matter of minutes, I was out cold. My friends carried me to the living room and placed a cold cloth on my head. They said I opened my eyes and stared for 15 minutes. When I came to, it was exactly 10:30 p.m. That night I was ill and vomited several times. I kept crying and thinking about my sister. Every time I thought about our mother, I felt depressed. The next morning at 7 a.m., my mother called. She was crying and extremely upset. She told me that my sister, who lived 200 miles away, had died suddenly the night before at exactly 10:30 p.m. Now, that's a classic one. Now, when does it take place? Well, usually it takes place when the geomagnetic activity is less intense. This is an example of a geomagnetic pattern recorded right here in our laboratory at Laurentian University. You can see the perturbations. This is a very active kind of night, a geomagnetically active kind of period. You're looking at various components here. On the other hand, on quiet nights, which is the next one, you can see the difference. In other words, when it's quiet, when it's geomagnetically quiet, the connections between all 7 billion brains have greater possibility. When there's more perturbation, it's like having more noise in the system. Very weak effects, but very strong and emotionally significant impact. Classic example comes from an experimental study. Remember, the most important philosophy that human beings have ever developed has been science and the methodology of science. The most powerful and potent tool has been the experiment. This is an experimental kind of study in where individuals who are dreaming in one room and simply engaging in ordinary dreaming in another room, a person is looking at a picture, a target, a picture. And what we find, and this is the work done at the Maimonides Dream Hospital, or dream studies, what we found is that when individuals are dreaming and someone in another room is looking at a picture, under certain nights, when you look at the dream content, is exactly what the picture was, the other person was looking at. And it's so obvious that not only does the dreamer know, but if you gave the description of the dream and a series of different pictures and said, pair the dream content with all of these pictures, they'll pick the exact picture that was being concentrated upon. Notice that the black circles indicate that when the geomagnetic activity was quiet, very, very quiet, that's when the dream content of the dreamer corresponded with the details of the picture upon which the other person was concentrating. Well, think about that. Every time you sleep near someone, are they influencing your dreams? Or at a distance, for that matter. But those are correlational studies or experimental studies. Here's a more important question. Why don't these experiences occur more frequently? Or is your brain more like a television remote that is randomly changing channels and ever so often overlaps with the source? What would happen if a procedure was developed that allowed direct access to whole information, to all of it? All right? Suppose there was a technology, and that's what we're talking about tonight. Can the ability to access information at a distance be trained? And the answer is yes, it is, and we've trained it. One such person is Ingo Swann, who helped develop the phenomenon of remote viewing. Ingo Swann is the individual, and this is Ingo. Ingo Swann was involved with the development of this remote viewing for the Central Intelligence Agency for the United States many years ago. The idea is, can you access information at a distance? As opposed to saying it can't happen, suppose we say it does happen. You realize, let me ask you this. If I told you 200 years ago that I had a device that I could put to your ear and you could hear what was going on the other side of the Atlantic, you would say that's crazy. But now we call it a telephone. Right? If I told you 400 years ago that I had a device which allowed me to measure and represent your friend, and I could play it back long after he was dead, and you could see that person, you would think it was magic. That's called filming. That's called a video. So think of it this way. Suppose there is a technology that allows us to have access to every bit of information that's available in the geomagnetic field from all of your brains. That's what he did. Well, let me show it to you. He learned to identify experiences that originated primarily in his right hemisphere as pure images and experiences. Here are some examples while he was sitting in a closed chamber in our laboratory here at Laurentian University and asked to draw what experimenters were seeing based upon random selection of targets. So here's what we did. We had experimenters walk by a hallway, and we would randomly give them an area somewhere within 15 minutes of Laurentian University. They had 15 minutes to get there. They would simply look at the target. These were randomly selected targets. Let me give you just a few. This is where you begin drawing. Curved building, tall vegetation, angular, natural, breeze, cool, convex, motion of some kind, a sense of vista, a smokestack in the distance, arena, trees, sense of a conveyor, smell slightly bitter. Now what I've done here, I've simply typed out what he's written down. He was an artist. He was a postmortem artist as a part of his training. Car, more than one. Slight slope. Grotto. Mine. Entrance to. Round and large. Distant stack. Road. Now don't forget, he's sitting in a chamber now, and we're measuring his EEG. And we've enhanced his capacity with the technology I'm going to show you in just a few minutes. All right? 2 major cuts near a closure. Depression, circular. Something goes in. Motion or movement. Conveyance motion, cars. And what was the target? You all know what it was. The target was the experimenters had gone to see Science North. There's what he drew. That's what it looks like. He had no idea what was going on. These were randomly selected targets. I'm showing the ones that are most conspicuous. There are many others. Here's a bird's eye view. This is all published in scientific journals, incidentally, and you can access them by simply Googling it on the web. Another target was a Catholic grade school with lots of windows, stalls for bicycles, a figure-8 shaped inside hall system, and a consistent pool of water along the edge of the property. Here's how he started. He had no idea. Remember, this happened on several days. And even the experimenters didn't know where they were going until they opened up the envelope outside the laboratory in the parking lot, and then they had 15 minutes to get there. Okay? Tall, sense of massive, windows, reflections, stones, hear water, pool. People walking, a sense of business, glass, bars, several of them, those bar-type things, buildings. Glass, throwaway, slope, colors. Now glass, now the bars he's talking about are like bicycle-type things, where you put in bicycles. And of course, he concludes it's something like a church or a school of some type. Remember, he's not from around here. He has no idea what the target is. But it's even more than that. If randomly selected photographs, particularly with emotive and meaningful components, were placed in another room, on a table, in envelopes, he could draw the details. Okay, so in other words, what we had effectively in another room, there's a table, roughly 100 different pictures in envelopes, randomly selected, one laid down. He's still in the chamber. We're measuring his brain activity. And he begins to draw. Here's one for you. Deep feelings. And I've actually, this is the actual words that type larger so you can see them. You can see his pictures. Dark but airy, undulating like a boat, watching, gloomy, stars, clandestine romance. I'll tell you about that later. Okay? Actually, it turns out in that table, on that table, 2 graduate students had, how shall I say it, interesting intimacies. Feeling of points or seeds, struts, electricity, feeling of awesome. What could possibly be drawn like that? The answer is the target, a tornado. How close can you get? Other ones, for example. This is one of the hidden pictures, and this is what he drew. World not responding, awash like a tunnel, morose, impact, hatred, into depths, police. This was a terrorist explosion of an airplane. And notice something very interesting. That even down to the components are being drawn. Next. Even abstract ideas. Remember, the whole point is to have a technology which allows access to every bit of information that every brain on this planet has. And this is a picture really abstract looking. Take a good look at those garbage cans and a number of other things, and look what Ingo Swann drew. People, dull target, wilderness like a window. Even something as abstract as that, details come through. Now, I want you to think about something, and that's the following. Just remember Alexander Graham Bell, the first time he generated a signal across the room. It was scratchy. He could barely hear it. But the point is, from that beginning of just a bit of information, now we have one of the most sophisticated technologies in the history of Western civilization. We have the telephone communication system. You've got to start somewhere, and then you perfect the technology. Okay, that's Ingo Swann. Was he always successful? Well, most of the time. However, the degree of accuracy was related to amount of 7 Hertz activity over his right hemisphere. Again, the right hemisphere, the one involved with your dreaming. This is the same frequency that the entire Earth generates. His accuracy was less when there were geomagnetic storms and the Earth's magnetic field was disturbed. So if the magnetic field was disturbed, he lost the ability. When you lost the connection, you lost the ability. For example, there's an actual EEG. Back in the days, we only had 3 channels. Okay, notice the red arrows. Those are 7 Hertz. This is a unique pattern. You don't find it very often. And the number of these patterns were directly related to how accurate he was. So in other words, the more he showed that activity over the occipital, right hemisphere, the more accurate he was in terms of the information at a distance. There's the ionosphere, and of course, generating between the Earth's surface and the ionosphere is a 7 Hertz pattern. And the more you get closer to that pattern, the more you seem to have access to everything around the Earth. For example, that 7 Hertz pattern not only has the same frequency as generated from the intrinsic aspect of your brain. Your brain has a natural frequency. Guess what it is? 7 Hertz. Based upon the fact that consciousness is recreated every 20 milliseconds. It's moving at about 4.5 meters per second. Just do a simple calculation of the circumference of your brain. It's about 7 Hertz. And the intensities of both the magnetic and the electrical components for both this and your brain are identical, capable of resonance. Here we have an example, of course, from the sun to the Earth. There's the Earth's magnetic field. And of course, when there's a magnetic storm, you can see that you get marked perturbation and the connections are lost. Now, we're not the only species like this. For example, fish very often communicate with electrical signals, magnetic signals they generate. Thunderstorms will interfere with that connection, like having massive noise, and their behaviors are distorted. So we're not the only species. Now, here are some examples of ordinary people drawing pictures of what they experience about a target when they are exposed to geomagnetic-like fields. In other words, is it just one kind of person, or just some people? And the answer is anybody can do it if you expose them to the field. Here is the target picture hidden in another room. This was a target picture, very much like the Ingo Swann procedure. And here's what a university student exposed to the appropriate magnetic field drew. Look at the connections. Remember, this is a situation very much like early Bell, because it's very, very scratchy at this point, but look at the essentials. Go ahead and connect them. We can see, for example, the emphasis on the shape, the eye. Remember, this is hidden in an envelope. The actual mechanical kind of individual, you can see from the outline yellow. And of course, there's always something called analytical overlay. Don't forget, this is right hemispheric. So this is all emotive and visual patterns, and it has to be translated to language. In the process of translating to language, very often you put your own verbal, how should I say it, overlay, your own baggage, your own verbal baggage on it, and can distort the signal, just like noise. Here's another target, hidden in another room. There's the picture, hidden in an envelope, person's never seen it. This is what the person draw if it's exposed to the appropriate configuration of magnetic field. Here's the drawing. Shall we see the connection? Take a good look. Not as sophisticated as Swann, but this is a university student with only 5 exposures to the procedure. Again, there's the woman in the back. All right. This fragment here, we're blowing it up a bit more, you can see. And finally, you can see that's purple glass written there. He's written purple glass. That entire area was purple. Now, this is not just a unique thing. This occurs repeatedly. And I'll tell you exactly what the patterns are later on. The most intense phenomena were these. When another person in another room is looking at a target and at the same time as the second person is sharing the same magnetic field, the accuracy becomes greater. So in other words, if you have one person here, you generate a condition that produces the same kind of magnetic field that influences the brain at the consciousness recreation pattern, what you'll find, if whatever that person's looking at, the other person can actually draw accurately. Well, let me show you. Can the average person access distant information? At Laurentian University, we developed a technology by producing a device whereby the same complex magnetic fields are shared by two people separated at a distance. When that happens, the two brains become one. Okay? So here we have the actual technology. You can see one chamber. That's what we call the octopus. It's basically 8 solenoids that produce a accelerating configuration, a second derivative magnetic field. There's what it looks like. There's the person in one room. All right, with the octopus, there's a person in the other. Here's some examples. The actual target picture that one person is looking at is on the right hand. You've seen that as the bridge down here in Sudbury. What they're drawn, what the other person's drawing, sitting in a separate room, and you can see the actual drawing, and you can actually see the letters or the words up there, and we've amplified them for you. Motion, bright long, vertical lines, wormhole, crowd, flower, explosion, passing stuff moving through. The essential aspects of that hidden target have been extracted and now are being shared by the two different people who share the same magnetic field. Their brains, both those brains are now effectively one. But the effect extends experience. If both people separated by distance share the same configuration of magnetic field, a light flash, just a light flash, to one person affects the brain activity of the other sitting in the dark in another room. So what we've found is that we can connect it to actual light. All right? The photon emission energy from the brain while a person is sitting in the dark is about 10,000 times less than the stars on a cloudy night, but we can measure it with photomultiplier tubes. However, it's 100 times more intense than the energy from the cosmic rays that pervade the universe. Now, I know you're thinking that this is really, really weak, but let me do an experiment real quick. Okay? Effectively, you're listening to me right now, and the sounds you're hearing are in the order of about a millipascal in terms of pressure. That's what you're listening. About 40 to 50 decibels, a millipascal. And presumably you're listening to me. Right now, above you, there's over 100 kilopascals of pressure. 1 billion times more pressure on your body right now than the pressure associated with me talking with you and you listening. Can you hear the atmosphere? It's 1 billion times more. Of course you can't. It's not the intensity. It's the pattern. The pattern is the critical thing. So never underestimate the importance of the pattern. It's not the intensity. And furthermore, if we take something like this, like one of these nice little cinnamon, and I drop it just like that. I dropped it this way. That's about a microjoule of energy. Now, for you to see a light in the dark, that only takes about 10 to the minus 17th joules. That's a decimal point followed by 16 zeros and a 1, which means this is a microjoule, which means that energy from dropping that right now would be enough to light up every eye of every human being on this planet. The critical thing is the energy and the pattern that detects it. Never think bigness is important. So, here's what happens. If, for example, we have one person in one room having a flashing light, another person in another room completely in the dark, and they only share the magnetic field, a special kind of configurational magnetic field that produces a synthetic consciousness, making both brains the same. When there is no flash in the other room, this person has theirs on the left. That's what's coming off the side of their head. If the person in the other room is seeing a flashing light, an ordinary, dull, flashing light, the person sitting in the dark, their brain also generates light because they're connected, even at a distance. Is there evidence of information transfer? We are now measuring photon emission from the human brain. That's how we think it's working. And you can see, if we take you, for example, and we ask you to sit down inside of a quiet room, and on the left hemisphere, the left side of the brain, right hemisphere, right side of the brain, notice that when a person is simply relaxing and just thinking about casual thoughts, for example, like something easy and refreshing, like how many hours I'm going to study tonight. On the other hand, if on the focus you say, okay, now I want you to think of white light. Just think of white light. Right? That's all you have to do. Notice the left hemisphere doesn't do anything. The right hemisphere, if you're relaxing, doesn't differ. The vertical axis is the amount of energy, and I can tell you what it is about 10 to the minus 11 watts per meter squared. All right. You can't see it. You need a machine, a photomultiplier tube to see it. But notice on the right hemisphere, when you ask a person to just think of white light, notice that under focus on the right hemisphere, there's almost a doubling of output. That's right. And now we know in neuroscience that it's very likely, Bocan and other people have actually shown this, that there's light emission from retina, that when you're actually thinking about white light, there's just not action potentials and neurons firing, there's actually photons being emitted within your brain, right? Actual photons, and we can measure them. The minute you have photons, you have access to almost everything, right? Now, when there are photons involved, the phenomenon of entanglement becomes real. This means that what happens to one person is reflected in another regardless of space or time. Here's a animation of what we're talking about. That's entanglement. In other words, entanglement means that effectively, the minute you have two people connected, photons here and photons here, we really don't know right now when that photon is flashing in the other room, is it the same photon that shows up in the other person's brain instantaneously, or there's simply entanglement. But if you have entanglement, you understand what that means. That means you have information at a distance. You change something here, you change something here instantaneous. Already physicists are doing this. They call it teleportation because they're a bit more dramatic. All right. But in actual fact, they've already done it up to over 100 kilometers. Change the polarity on one, the other one changes instantaneously. That's the first stage to having information from everywhere. Now, if one has the technology and access the appropriate patterns shared by other brains, information can be accessed. We can amplify, concentrate, and control what has been happening only occasionally for centuries. Now think about it. Like watching lightning. We did it for thousands of years, hundreds of thousands of years as a species, and then we mastered electricity. Look at the difference. We watched birds fly, wondering what it would be like. We never did have wings. We never developed them. But now we can fly. We call it an airplane. If you can imagine it, it can be done. And that's why, because the brain is matter. It's based upon the physical principles of the universe. And if you have that capacity to imagine it, that means the potential is there for it to be done. Because our brains are reflective of the essential aspects of the matter of this universe. Now, Sean Harabanz, a classic example of extraction of information. This is the man who knows your memory. There's Dr. Webster actually extracting some blood or actually injecting some radioactive material into Mr. Harabanz. We were the first to demonstrate that when he's engaging in reading another person's memory, it's not all hocus pocus. What really happens, a part of his brain that's been different from the time he was born shows an increase in activity as measured by single photon emission computerized tomography. Very specific to the right parietal lobe. Here's Sean Harabanz, again an animation. He's looking at a picture. All he has to do is look at a picture of the person about whom he's talking, and he begins to talk about the person's past, often embarrassing things that only they know. How can that be done unless you have access to memory? Right? It's not written anywhere. We made an extraordinary discovery about Harabanz's brain. The energy associated when we measured, don't forget, the experiment, most powerful tool we've got. You can speculate until you get extraordinarily enthusiastic to the point of inebriation, but unless you've got the experiment, you don't know. So we've actually did experiments. We brought him up here. We measured him repeatedly. Okay. We made an extraordinary discovery about Harabantz's brain, the energy associated with the small decrease in the Earth's magnetic field around his right hemisphere. We were flabbergasted when we put our magnetometers around his head. His brain actually distorts the local magnetic field. Small amounts, but measurable and reliable. Okay? It was equal to the energy of the light emission from his brain. You think that light emission was interesting. You should have seen the photomultiplier tubes when we put it around his head. The needles are visibly showing increases in activity. And the more the photons increased, the more the magnetic field dropped. And that energy was equal to the activity of the neurons. We actually calculated the number of neurons that he was showing activity by looking at our quantitative EEG. In other words, conservation of energy. The longer Mr. Harabantz was close to the subject, the more the subject's brain began to show the patterns of Harabantz's brain. Let me give you an example. Harabantz and the subject. This is our EEG. Okay, single channel, obviously we do 1020. Okay. But notice that as he sits there, they become more and more synchronous. At that point, when they become synchronous, he actually begins to extract information and begins to tell information to the other person, the person sitting there, information that is only they know about. Now, if you haven't heard of Harabantz, well, let me put it this. There used to be an ex-leader of Iraq who hid in a hole. Guess who gave the information for where the U.S. government found him? It was Sean Harabantz. The point is, if you have access to information, you can get it from anywhere. But we have to know what the mechanism is. Well, right now you say, that's unbelievable, Doc. That's so far-fetched. Well, let me ask you this. If you now have a radio system that's really, really good, you can pick up a channel from anywhere in the world. 500 years ago, if I'd have told you that, you'd have said that was crazy. We think his brain became connected with the brains of the people nearby through the Earth's magnetic field. Something like this. It seems to only work when he's close. Okay? So as he gets closer and closer, and we see it, we repeatedly, time after time, the more they're close to Harabantz, the more their EEG activity became like his. And we suspect that what happens is he began to extract information. I'll show you how in a second. During the connection, there was enhanced brain power at 7 hertz over his right hemisphere. You can see the red arrow. That refers to specifically the 7 hertz band coming off his brain. Remember the 7 hertz, intrinsic pattern to the Earth itself, the same pattern that Swan had, and seems to be something fundamental. Now, the 7 hertz is tied to something called the hippocampus, the gateway to memory. And if you access that, you access all the information that's being consolidated in your experience. Remember, your memories are nothing more than synaptic patterns. That's all they really are. And the gateway to that is the hippocampus. Is there another homogeneous field to which all of us are exposed? All right. There are the communication systems of the web, internet, and the massive electromagnetic matrix that it creates. I'm just giving you one. There's others, you know. Let's take a good look at it. That's sort of a diagram of it. You can see that effectively right now communication systems are so pervasive that we all are immersed in this background that we call communication systems. You know, interesting thing, at one time we used to have radar sent out and reflected back in order to see things at a distance. Now the electromagnetic density of all the communication systems are so great, they generate a shadow. We don't even have to generate radar emission anymore. We're living within the shadow, quite literally, of a massive electromagnetic field generated by communication systems, which means we're immersed, all of us, in a homogeneous secondary field called the communication system, called the modern technology. And much of it is pulsed, very much within the range of the brain, the human brain. So I ask you this question. What would it mean if you and everyone else had access to the information of every other brain on this planet? I want you to think about that for a second. In fact, I'll repeat it. What would happen, or what would it mean if you and every everyone else had access to the information of every other brain on this planet, so there's 7 billion of us roughly, what would happen? First of all, knowledge is the ultimate power. And as you know, revolutions occur when about 50%, and this is historical, when about 50% of the population becomes educated, that's when you have revolutions, historically, okay? When they become literate. That's why people are often, and dictators are often against literacy or access to free information. But what would happen? Knowledge is the ultimate power. First of all, the control of populations is based upon a few having discretionary information over the many. Call them governments sometimes, right? Or administrations. Okay. Economic advantage derives from proprietary information. If everybody had equal access and knew what the other person was thinking, do you think there'd be rich people? Think there'd be poor people? And finally, the success of governments depends upon sequestered facts. Do you really think governments could have their power that they have right now if you knew everything they were doing? Of course not. We have seen the impact of leaking information through the web, haven't we? It's enough to make some people want to take the person who leaked it and bring them back and basically prosecute them for treason or some other kind of confabulated reason. What would happen if you had access to all information from every other human brain through a new technology that is now being developed? And the answer is no more secrets. Thank you.
Do you think with the constant bombardment of all that information that eventually it would be a case of seeing too much and people just wouldn't care? And so you could hide the secrets in plain sight?
If you have access to information for the average individual and you make it such that all 6 billion, 7 billion people see it, what most people do is they extract the essence. Right? So I don't think you can hide important things. Critical things people see right away. I hope that answers your question. I think you're talking about sensory overload. And the answer is that, well, I'll put it this way. If somebody suddenly realized that there's going to be a limited amount of food, I think most people would figure that out pretty quickly. Right? You wouldn't hide it very easily. Right?
Fascinating talk. I'm very impressed. I don't know this area very much, but one thing I kind of try to understand is that since you or anyone else can have a vast amount of information you can get through this kind of system, then specificity, how you can achieve specificity. For example, in the beginning of your talk,
right,
you're talking about the sister's sudden death who was 200 miles away.
Right.
And how on the earth there are 6 billion of different people on the earth and you have access to all this brain, then how can you specifically connect to your sister, for example? Do you think you have some kind of physiology difference or genetics involved in that?
Well, what we can do, in terms of the question was, there's 6 billion, 7 billion sized brains. How do we get congruence? First of all, we know that genetically the congruence is much greater than suspected. And what we don't know right now is the actual fine-tuning, the actual, for example, if you're playing a radio, I mean, if you have systems or stations that are very, very close together, they tend to overlap. So the critical thing is how much discrimination there is. If we took a look at the fact that are all the brains that different, and the answer is probably not. There is going to be some overlap. There's going to be some distance factors in terms of we know that most of these phenomena tend to occur within a couple hundred kilometers. And the more genetically similar they are, the more likely there are to be congruent. In other words, identical twins, people who have reinforcement histories that are shared, are much more likely to have these kinds of connections. So to answer your question, it would be sort of like the technology we have to develop. I mean, there used to be a phenomenon called a foxhole radio, where if you put together the right carbon and things, you could pick up local channels, but a lot of channels were going, it was all gobbledygook. And so we got better kinds of technology, and now we can separate out these different signals. So right now, think of the brain as that simple old radio system. And with modern technology, or with more sophisticated understanding of the brain, we may actually be able to discriminate these different sources. I don't know if that answers your question, but that's how I would accommodate it. The other feature, too, is to realize that, well, right now, I have a board here. At any given time, that's how much energy is associated with your thinking, the single action potential. Let's assume, for the sake of argument, you look like a very intelligent person, that you've got, let's say, at least 10 billion neurons that are activated. Okay, so that would be basically 10 to the minus 10th joules. Okay, and then assume that they're all firing about 10 hertz. That means roughly you got about 10 to the minus 9th joules. That's how much energy, about a nanojoule, is associated with your thinking at any given time. Now, in your lifetime, how long are you going to live? What do you figure?
100 years?
Let's be really nice and give you a couple gigs, okay? We'll give you a couple gigaseconds, okay? So if you live to be a couple gigaseconds, or about 10 to the 9 seconds, okay, the amount of energy, just a thought associated with your thinking, would be about a joule. Just your thinking. We're not talking about metabolic activity now. So I'm not talking about the fact that you're generating about 10 watts, 10 joules per second from your brain because of the blood flow and because of the metabolic activity of the cells. I'm just talking about that component associated with your thinking. So that's how much you've got in your lifetime. Okay? Now, the Earth's magnetic field, okay, is effectively, for all practical purposes, if we can actually calculate it out, something has a magnetic dipole such that it has the capacity to store roughly about 10 to the 18th joules. Right? So that means that for all practical purposes, whatever this information is, all right, and let's multiply by the number of people on the planet, we got lots of information to store, lots of energy potential to store it everywhere. You're right, the critical thing is how to get it back. That's the hard part. Right. So really, if we talk about the energy involved with your entire life, my life, all right, all the neuronal activity associated with memory, it's only about a joule, okay, just the electromagnetic component. And if it's represented within the energy of the whole Earth's magnetic field, as I showed you earlier, you could store every memory that ever existed. Critical thing is the access. That's the hard part.
So what you're saying, if I understand correctly, that you can, your brain can store
right.
all of this information, but when you need to have access to specific target, what you're saying is you can have that.
Well, effectively, what we're saying is the following, is that, well, let's take your brain. You look like you, just a second. Yeah, okay. All right, let's take a look at your brain. Your brain, for example, probably has close to something like 10 to the 13th synapses. All right, 10 to the 13th synapses. That would be a good guess. And you could talk about that as the upper limit of information. Okay? So you're getting into the terabyte range. Okay? I guess the big thing in terms of differences is those shapes. All right? That's how many synapses we all have, at least in the cortex, cerebral cortex. But the other feature is everything is slightly different. Okay? Now, that's the specificity. That's going to be the hard part for now. But with computer technology, it makes it much easier to model.
In order to preserve secrets, is it possible for, say, governmental entities to induce a condition much like a geomagnetic storm artificially?
Well, actually, I'm going to answer that question because we've actually done the experiment. Ingo Swann, you saw his data. And we actually decided to see if we could block Ingo Swann. And so what we did, and you're going to love this, guys, what we did is we had the targets in the other room, and we had our solenoid here and our solenoid here. Okay, so here's our solenoid generating a magnetic field. And incidentally, if you really want to understand the nature of how this works, consciousness is a second derivative. It's a rate of change. And the minute you begin to play with that, as we have in our laboratory, you begin to alter consciousness capacities. People are aware of things they're typically not aware of. We've done this on many occasions and published elsewhere. But for Swan, what we found is that he was tremendously accurate. But if we generated a magnetic field across the target with a function generator or with an ordinary kind of DOS system, nothing happens. The only thing that blew it away is if we use Windows. If we use a Windows-based system, if you've ever seen Windows, next time you get a chance, go ahead and do a spectral analysis. Windows saturates every frequency. It blows away every frequency. And that was the only time he could not detect, is when we used a magnetic field generated by a Windows system. Okay. So that tells you something, doesn't it? It's a great insulator, a fantastic insulator. Also, one of the interesting things that are taking place as the amount of communication systems increase, the number of unusual phenomena, the so-called paranormal phenomena, are decreasing. In fact, we now realize that as the density for cell phones and other kinds of electronics increase, the number of spontaneous phenomena, particularly in Britain, called haunts and others, are decreasing at the same rate. And it's not simply an artifact of people becoming more educated and less interested in the phenomena are simply disappearing.
So if we start with the assumption that there's a materialist basis for consciousness, and we realize that the brain is a finite organ, then it seems to stand to reason that there should be a sort of quantitative threshold for the amount of consciousness that any brain can experience. Would that be fair to say?
A quantitative threshold. At the beginning, certainly, we know the phenomenon called blind sight, where individuals who are technically blind, but yet they walk around objects. If you look at their brain activity using a PET or fMRI, you will find there's still a little bit of activity going on that allows areas of their brain that will allow them to unconsciously move around things. That's true. I mean, one of the things we found in modern neuroscience is that right now there's probably all kinds of changes taking place in your brain that you're not aware of. Well, at least until you start to dream. Because when you're dreaming, you suddenly become aware of these internal states. That's why dreams are so important in these phenomena. But on the other side of the coin, there are really two states, and you can think of it this way. In fact, this is something which is always the case. We have two states. We have matter and we have energy. Corpuscular, structural things, which takes place in synapses, and then the electromagnetic patterns, which technically are simply energetic, or you can think of it as force versus energy. And we know that when it comes to something like human behavior, we know that about 20 minutes of your memory right now, if you've been listening, is labile. It's electrically labile. If you were suddenly hit with an electric shock or something equivalent, you'd have amnesia. And the average is about 20 minutes, assuming no edema, assuming no swelling of the brain. About 20 to 30 minutes. So during this time, it's electrically labile. Electrically labile. Okay? During that time, this electrical ability is translated into the growth of changes within the brain. We call them spines on the dendrites, which are the little connections in the cells within the brain. It takes about 20 minutes for these things to differentiate and to grow and to make those connections. And of course, that is the representation of all of your experience. But here's what we've been finding. We've been finding, yes, in your individual brain that's the case. But just suppose during the same labile period, this information is being represented elsewhere. The time it takes for information, any electromagnetic information, and you can calculate yourself, to go from a brain, for example, into the geomagnetic field is about 10 to 20 minutes. In other words, just suppose there are two phases. One that go into the individual brain, represented as synaptic patterns, which, when it dies, it's gone. But what about the other information that's been represented elsewhere. And is that physically possible? Absolutely. Does the Earth's magnetic field have the capacity to store that energy? Very clearly. What's the mechanism? That we don't know. But it's going to be like a hologram. Something like a hologram.
So just working on the basis that the extraction of information is photonic based. And well, that would have to take into account all the quantum mechanics behind that. So without really bringing up cats in boxes, how can we be how could we be sure that we're actually extracting information by sending photonic light into someone's brain without actually changing the information? It's like, let's say, like everybody starts building cerebros in their own bedrooms or whatever. Okay. And we're starting to.
Chat with me later. I think we have a plan.
And everybody's starting to infiltrate each other's minds. Are they actually changing that other person's mind? Or are you actually just seeing the image? Because it's like chicken or the egg.
Yeah, I mean, without going into this sort of lame philosophical argument that what would happen if one night everybody if all the rulers of the world were changed, would you know it if you were using a ruler to measure it? And the answer is no, you wouldn't, because you've changed the reference point. The issue is that is the approximately 7 billion brains of our species being changed all the time? We don't know it because we don't have a reference point. Interesting philosophical issue. I think the critical thing to understand is that this phenomenon is like any other phenomenon. Some people have more of it than others. It's normally distributed. And the other feature is you can learn it. All right? And the other critical factor is that everything that we've ever done as a civilization, we've borrowed from nature. We've taken lightning and we made electricity. We watched birds and now we have flight. Even something as simple as what original Alexander Bell did. I mean, in terms of the small changes that produce the little scratchy sounds that now we use to generate music and all kinds of things. The phenomena are already there. The critical thing now is the engineering and isolating the technology that will allow us. I want you to just think for a moment, what would it be like if every experience you've ever had, and even the ones you forgot, everybody else had access to?
Another thing is that while you were doing your experiments with Swan and Harabands, were the participants or the people that were being read, did they feel something back as though, like could they feel that there was someone inside their brain?
No, they did not. Anyway, most people didn't. Right. Just like the radio doesn't feel it's picking up the channel, okay? It's just simply an experience that people have. Great question, though. Thanks.
You've spoken
because
about...
most of the time when thank you, just a second, because what I'm chatting about now, if you remember No More Secrets, I mean, I want you to imagine just for a second that governments had no secrets. University administrations had no more secrets. All right. What would it be like, all right, if that power of keeping away information, of that power of ignorance was no longer present? The world would be different forever. Go ahead.
You've anticipated my question very nicely.
Okay.
Thank you. You've spoken of what happens to governments, large populations, when a certain proportion of people become literate.
Right.
And literacy, of course, is a way of sharing information.
Right.
So perhaps what you're speaking about now with No More Secrets, this is a new sort of literacy in which we're seeing really, we're being able to read the record of the entire human population forever. Well, so therefore, what do you suspect would happen? What would you predict would happen once this, this skill that can be learned would be achieved by a significant proportion of the population?
Well, I would say the following. I mean, just suppose right now you could feel the searing, burning bullet of whoever's being killed in northern Africa right now. Or just suppose right now you could feel the unbelievable torture of having your stomach empty in Central Africa. I'll guarantee you there'd be no more war and there'd be no more starvation. That's one of the implications.
An empathic civilization.
That's right.
Thank you.
Yeah.